So my application runs on the blockchain. So that means I created some code in a language called Solidity. It's pretty close to JavaScript. And then I sent that to the blockchain. So every node on the network now has the code, has a version of the code, so a compiled version of the code, and can run it on their own computer. So if there are 100,000 nodes, all of them are going to run my code whenever we interact with it. And then whoever does it faster and solves the problem afterwards, they're going to get a lot of money from it. So for the demo, I think you see my screen. I need to log in, so 1 second. So I have an extension that's called MetaMask. So that's this fox that's following the mouse. So this thing is just a Firefox extension that holds my keys. So I'm going to show you, I have a couple of accounts. I can create a new one, for example. Hello, for example. So when I do that, I'm just creating a private key. This extension is storing for me. And then I have a public key that you can see here. So this public key now is my account. I don't know if I switch to it. Yeah. So this public key is my account. So I can go to, for example, scan. So that's something. So that's a platform, for example, that runs their own nodes. So they have all the information about the blockchain from the beginning of times. So if I look at that, for example, I just created my account, so there's nothing in it. If I look at another one, I do a couple of things with it. By the way, it's a test account, it's not real money, of course. But yeah, so if I look at another one I have there, we're going to see a couple of things. So I have some things, I don't know exactly what's going on. Oh, sorry, it's because I'm not on the right network. Ring to buy. So that ring to buy is the test network, so it's kind of a staging environment. If we look at that here, you're going to see, yeah, some transactions. So when I played with on the Ethereum blockchain, I sent a bit of money. You can see there, I received a bit of money and so on. So all of that is stored in every node that wants to participate in the blockchain. And the way we know it's the correct thing, well, it's there's a consensus mechanism. So if more than 50% of the nodes agree that's the correct state, then we can say, okay, it's the correct state. But if you want to run your own application, you might want to run your own node and know that you're not cheating the system. So you can have your own data stored locally and create yourself. So that's usually the way it goes. So back to the application. So I don't know if you know what an NFT is, but so let me go back to my other accounts. So an NFT is usually people are joking that they are JPEGs stored on the blockchain. So yeah, for example, that's a JPEG, and when I created this one, I sent what we call a transaction to the blockchain. So that means to all the nodes saying, okay, I want to store that JPEG on the blockchain. So the first node that was able to accept that calculates the correct nonce, that's the number I was talking about, and calculate the hash. So it's finished, let's say, with 5 zeros at the end. So it could have taken them, I don't know, 5 minutes, 10 minutes. Then they got all the money I gave them to create that. So every time, what you have to get out of that is that every time I interact with the blockchain, I need to pay a bit of money for people to actually run my code. So I'll show you how the platform works. So I can create a new, so these little things, I call them crypto blobs. So they're just random JPEGs, actually SVGs, generated randomly. So whenever I create a new one, I can call it Thomas, for example. There's already a Thomas, I'm going to call it Thomas 2. It's going to ask me for some money. So you can see here it's asking me for 0.000589 Ethereum. So if I click confirm, it's going to take that money from my account and send it to whoever's going to validate my transaction. So I can click that. It's going to be included in the list of transactions that need to be processed. And then whenever a node, a computer on the test network takes my transaction, computes the correct number, and then dispatches that to everyone else. This just happened. Then my code is applied. I'm going to show you the code in a minute, but it's very simple. Just create a random number that you can see here. And then I have some JavaScript code to take that number and generate a random PNG from it. So when the DNA, for example, is that, then it generates this picture, and the DNA is that, generates this picture. So each one of them is completely unique. And then if I want, I can, on my application, so that all of that is code I've written, but all the validation behind it is the blockchain, using the blockchain. You could think of it as I'm writing my own backend and front end, and the blockchain is kind of like AWS cloud provider. So it's providing all the infrastructure I need to send a bit of money. In that case, the money is not on the developer, but on the user of the platform. So me, as a user, when I want to interact with it, I need to pay a bit of money. So to continue on what my application is doing, I can also send my crypto blob I just created to someone else. So you can see I have a couple of accounts. I have Bob, and then I have Hello Beat I just created. So I'm going to connect it. I'm going to copy the address. I need to go back to my account now, sorry. So going back to this, I want to send this crypto blob from my Bob account to my HelloBeat account. So I copy it in the clipboard, this. So I need to send it. Okay, there's a bug. Let's pretend it worked. So if that worked, I would have had this pop up, and then I would have had to validate it. I can also list it for sale, so put it on a public marketplace that everyone can access. So if I want to sell that for 0.1 Ethereum, for example, I would click that, and hopefully it's going to work. Yeah, cool. So yeah, this just pops because my JavaScript code called the extension and then told me to send the transaction, going to validate that, and same thing again, it's going to load for a bit of time until someone processes my transaction, takes the money I just sent, and okay, so it worked. So now I can see in the marketplace, there are my 3 blocks. So this data, it's making a call to the blockchain. So calling a node on the blockchain and asking the node, okay, what's the data on my application? And the data, for example, for the marketplace is this blob is on sale for this amount of money, this blob is on sale for this amount of money, and this blob is on sale for this amount of money. So let's dig into the code. Maybe it will make things a bit more clear on how it works. So the first step is creating a contract. A smart contract is like the equivalent on what we would be doing. That would be backend code. So I would just be creating an application, let's say, or a server or something like that, an API.
Thomas, can you enter some sort of presentation mode? Not that professional in VS Code, but is there something? Maybe just increase the
Command plus.
Command plus. Okay.
Command what?
Presentation mode.
Command what?
Plus.
This like on a browser. Just pretend we're old people.
Very old. Thanks.
Can you see a bit better? Yes. So yeah, this is the equivalent in backend development. My contract would be like a service, an API, and then it would have functions. So the functions would be a public method. So for example, this one, create blob, is the thing I called when I was clicking that button, right? I gave it a name, and the function, the actual function is called somewhere else. I mean, I'm exposing it somewhere else, but actually this is generated inside that contract. So whenever I do that, I'm storing some data on the blockchain, and we do that by just updating some variables. So this one, this contract is saying, where is it? There, so there's some data. I'm trying to find where this is defined. Yeah, oh yeah, sorry, it's there. So I'm saying, okay, I have three things I want to store on the blockchain. One of them is I have blobs. Blobs is a struct like you would have in any language. So I have some blobs that are public and stored on the blockchain. I have a mapping, so that's a map, a dict, a hash map, or anything you can think of. So it maps a blob ID, so that's the index in the array, to an address. An address in the blockchain is my account, right? It's what I have right there. So my account, for example, is this. It starts with 0x and then some hexadecimal numbers. So that's how I know who's, so this one is how I know what blobs exist. My blobs, again, is this thing I created. It's not a blockchain thing. It's not an Ethereum thing. It's my application. So I have the blobs that look like that. I know who's owning each one of them. And then I know how many blobs I own on my account, for example. So whenever I'm calling the function create blob, that's called when I click that button, it's going to update these variables and yeah, store them on the blockchain. So for that, blobs, that's my array of blobs. We're going to add something, we're going to say that it's owned by whoever pushed the transaction and paid for the transaction. And then I'm going to say, okay, this guy has one more blob now. So once I have created that, I need to deploy it to the blockchain. So I'm using a tool that does that pretty much for me. So it's compiling it to some bytecode and then sending it again. It looks like a transaction, but in the end, if I look at this one, I need to find the address at the end. So again, it's just public data that's sent to the blockchain, and it's duplicated on all the nodes again that participate in that. So if I look at that and then I go back to my blockchain explorer and pass the address of my contract, that's the contract of the address. When you deploy something, it gets an address. If you deploy a contract, you deploy your code, it's going to get an address. So if I look at that, and I can see it's being deployed about 6 days ago, and it's been interacted with a couple of times. So once I have that, I have my backend. It's called the smart contract. I need to interact with it. So you could interact with it directly from some websites that allow you, because it's public things, right? So you could interact with it. You could build your own front end for it if you wanted. You could use public front ends that are able to interact with every contract that's there as well. But to make it a bit better, I created my own front end. So I have a front end there. It knows which contract to find just by passing the address. So I have the address. I can find it publicly there. So that's the compiled code for the contract. It's just some bytecode, right? And there's a VM that can execute that bytecode that every node can run. I can run that locally if I want, for example, or just run my node on the blockchain, and it will be able to execute every smart contract that's ever been deployed. So the front end, how does it look like? First, there's some connection that needs to be done. I don't know if you saw when I loaded the application, there was something that happened on the back. So it saw that I had my MetaMask application, so it was able to see that I I own an account on the blockchain, otherwise it would have stopped it and told me, okay, you need that. Then it was able to find the smart contract on the blockchain. So that's, again, all of that is code I wrote, all the checks there. So connected to the smart contract means looked at this address, found that there was a contract that it can interact with, and then it can send things to it. And finally, connect my account. It again interacts with the Firefox application, Firefox extension that's called MetaMask, and then it can see all the things from my address. So it can get my address, and then if you look at the address of my account, you're going to see that there are some things in there, and on that smart contract that I've deployed, you can see the state, and you can see that going back to the contract, you remember there was a mapping from owner, from blob to owner. So then my front end is able to look on all the blobs there are. It finds the one that I own, and then it's going to be able to display them over there. So I'll try to show you a bit of code. So, so what we do when we start the application, I think it's better to go there. So register is what happens when we start the application. So I'm going to check if the extension is there. If it's not there, then I display an error. If I'm not on the right network, for example, if I'm not on the test network, but I'm on the actual main network where we're going to pay for money, it's going to complain about it and ask me to change. So that's all JavaScript code interacting with the application. Then, as I said, we're getting the contract. We're injecting, so we're using a library, JavaScript library that's able to query the blockchain and see what's in there. And then if I can show you a bit of more code in there. So what can be interesting, for example, refresh blobs. Yes, but where is that? Fetch. So whenever I load the application, after I'm connected, after everything is correct, and I know I have MetaMask, I know where the contract is, I know what account is connected, and I'm going to interact with the blockchain. So getBlob would be a good one. So getBlob, that's my JavaScript method that is called by my application. Is going to call a method on the contract. So let's say there's a blob method. I know there's a blob method on my contract. It's going to call it. So that code with all of that is going to interact with my MetaMask, with my Firefox extension, tell it open a window. Sorry, no, not for this one, but it's going to interact with the blockchain, get the state of my contract and see that I have this block, for example. When I clicked the other thing, so there was a button list for sale. It should be in there. Just trying to find where I'm doing it. List for sale. Yes. So this thing does the same thing, right? There's a method on my contract called list block for sale. We're going to call the method with two things: the ID of my blog and the price I was setting in there in the box over there. So if we look at that on the contract side, so it's going to call that function. I'm going to pay a bit of money to interact with the blockchain again, and then it's going to do these actions. So for this thing, it's just updating a map of current auctions. They're not really auctions, they're listings because we're not auctioning. But yeah, for example, we have these three blobs, and this is where it's stored. So yeah, so all the application is working like that. So first I write the contract, so my backend, and then I write a front end that interacts with the backend, And every time I need to change the state, I need to pay, the user needs to pay a bit of money. Every time I read the state, this is for free. So I won't explain every bit of the application because I don't feel like it will be interesting. But what I got out of that project, I think the interesting bits are like to do that, to do a marketplace where you could actually send real money, because this is the test network, but if I just deployed it to the main network, I would have like a fully functional marketplace, something where you can sell things, where you can send money to other people, where you can own objects and send it to other people. And that was very easy. I didn't have to do anything about authentication. The MetaMask extension does it for me. I didn't have to interact with banks. The blockchain and Ethereum does it for me. And my application was functional. I mean, I could start doing some very interesting stuff in a day. So in that place, I think it's very interesting. So I can see a lot of use cases where you could have very cool applications where you don't have to spend months setting up contracts, knowing a lot about a lot of different things like authentication, security, banking, regulations, and so on. Just set up your application, you do some JavaScript, almost JavaScript code, and then you're good to go. So I think I'll stop the presentation there. Is there any question, anything? Oh, there's a question on the chat. You pay gas.
Nikas was asking actually.
So in order to connect, you don't pay gas. And every time you're going to pay